today we are going to talk about the MWD services or measurement while drilling. But first, I think it's pretty important to know about the pulses. Okay, Jessica, pay attention to me. In your simple life, they are in anywhere. We can imagine them. Pulse flows can occur in many biological and natural phenomena. For example, your heart generates pulse flows when pumping the blood around the body, right? The presence of each pulse ensures that there are enough oxygen and nourishment for your body to work efficiently. So, are they important? Oh, and this is how it works, by the way. So here's the thing. What is measurement while drilling or MWD? Well, most people who are working within the drilling industry have heard the term MWD, but what is exactly and what is its significance? Yes, with advances in directional drilling, it's necessary to know the drill bit coordinates in 3D space during drilling to steer it better and follow the planned old well path. Also, it would be extremely useful to driller to know the downhole conditions like wear on bit, or the torque and temperature, as well as rock formation properties, to make informed decisions during drilling. All of these measurements should happen while drilling, and that's explain where MWD comes from. But how it is done? The main challenge is how to transfer all the data from downhole to surface. So we can put a package of sensors in the drill stream, but there is no wire, okay? This is the most important. So the question is how to achieve this. Like every challenge, engineers have to come up with innovative solutions. Let's list what we've got in downhole: drill pipe, drilling mud, and rock formation. Interestingly, there is an MWD technique developed using each of these mediums, namely acoustic, mud pulse, and electromagnetic wave telemetry respectively. Recently, water drill pipes have been introduced to the industry, but there is still scope. Its application is limited because it's so expensive, okay? So the key to all of these approaches is to encode the required measured data into pulse wave in the form of acoustic, fluid pressure pulse, or electromagnetic wave, and send them to the surface where a decoder converts all the pulse data to a meaningful numbers, okay? So all of these methods possess their unique shortcoming and strength. However, mud pulse telemetry is the most popular and least intrusive operationally, and is the focus of this video, okay? As with any wireless telemetry, the mud pressure pulse telemetry process comprises the following subsystems: downhole measurement system and mud pulser, encoding the downhole measurement data into pressure pulses, and decoding the pressure pulses at surface. It is a beautiful combination of these three that they should be aligned to get the data well decoded at surface. And there are a lot of parameters that we need to consider when preparing the tool, when assembling the pulser. We need to know how the drilling mode will be in that section. How are the pumps working, for example? How are the current times when programming tools according with the sensors that you have? There are a lot of things that we need to consider to get these three subsystems work properly. And it is here because when it is a match, there should be a match to decode the data, because maybe the data is inappropriate times, then you're gonna die when you're drilling because your data won't be decoded, and it is so sad. We don't want to be in that position, but it could happen if you don't know, or if you are not paying attention of what you are doing with your tool and with your entire process. Okay, so let's talk about a little bit the MWD tool. MWD tool is an electromechanical system which consists of directional sensor package, mode pulse generator, and power source, which can be a battery or turbine generator assembly. The MWD tool assembly is placed in a monel, and a monel is a non-magnetic decoder to reduce the interference with magnetometers used for azimuth direction measurement. MWD tool is usually placed above drilling motor in V shape. It's usually placed above. If we have, okay, just a second. I was thinking about the idea to have a V shape. This is the mud motor, and this is the drill bit. If you have for example, an LWD services, so you will need a LWD tool. So this is logging while drilling. This is the mud motor, and this is the drill bit. And here is the MWD, just like here. The MWD is above the motor, or the mud motor is here. Okay, let's imagine that we have the MWD, and here is the pulsar, okay? And inside the pulsar, there is a poppet, and there is an orifice, just in this part, okay? Imagine that, okay, the driller pumps up the pumps, so the drilling mud is going to pass through the drill stream, and the flows in this direction. The first thing that the mud flows is going to find is the poppet above the pulsar. Is the poppet. Imagine that the poppet is right here in this position, okay? It have a measure, and also there is an orifice. The positive pulse is created, as I told you, when you momentarily restrict the mud flow. And how it is done? Okay, there is a valve, there is a mechanism, but what really happens is that you have the poppet and the orifice programmed just to close and open, okay? And obviously it's going to pass depending of the drilling section, of the formation of your tool. There is a time. The entire flow will pass in this small section. So if you do a change of this pressure by doing this, you're going to create a mud pulse. When you try to teach this in Spanish, it's easier than when you are trying to do it in another language that is not your own or your mother tongue language. So if you have this increase inside your drill stream, then it's going to create a mud pulse. And it is positive because it is an increase inside the mud column, okay? This generated pulse wave travels back to the surface, and it is detected by a decoder pressure sensor. This technique is used for telemetry systems which need slow rates of data transmission, okay? And there is another way to generate the mud pulses, the negative pulse. Pulses are generated by venting. Remember that you have your drill stream, you have your mud motor, for example, your drill bit, your mud motor, you have your pulsar. But in this case, when we talk about the negative pulse, there is a mechanism or a venting the drilling fluid from the drill stream into the annulus. There is a mechanism there that allows that the mud flows go out of the drill stream. Obviously, if you have a polarizing system inside your drill stream, obviously you're going to observe a decrease in your pressure measurement. So mud pressure decrease during venting and pressure pulse will generate this decrease. I'm going to show you in this picture. I hope it helps. This technique is rarely used in the industry. Well, it's a bit expensive, by the way, but it's an interesting way to have a faster data. And also there is another system or another mechanism, and there is the continuous pulse, okay? So a continuous pressure pulse is created by a rotation of a rotor over a stator. It's called siren, since the principle of its function is similar to the sirens used in ambulances and tornado warning alarms. This technique is used for faster telemetry systems. Now we have to know how to encoding the downhole measurement data on pulses. Okay, the process of encoding downhole data on pulses is called modulation. Okay, have you wondered what if FM and AM stand for when tuning to a radio station? They stand for frequency and amplitude modulations respectively, okay? They are different techniques to convert the radio signals, these sounds, to electromagnetic waves broadcasted into our radio receivers. In this process, first, the data is converted to a numerical or a numeral system like binary systems, including series of ones and zeros. And when we are talking about AM or amplitude modulation, zeros and ones are transmitted by varying the amplitude of signal, while the frequency is fixed. Alright? And when we're talking about the FM, it is done by varying the X frequency, while the amplitude is fixed. Then we need to decoding the modulated pressure pulses at surface. And the main instrument for decoding the pressure pulses include a pressure sensor and electromagnetic box, which converts the analog data of pressure pulses to digital data for a signal processing. Alright? Due to existence of noise mainly from the mud pond at the surface, the generated signal gets filtered out, and it is a code to obtain meaningful engineering number for the measured physical parameters. So the process of signal decoding is the reverse of signal encoding, which was explained earlier. The decoded data is displayed in real time on a PC as shown on this picture. There is another thing that is pretty important to be careful about, and this is the pulse wave attenuation. Pressure pulse wave usually travels several thousand feet against mud flows in your stream to reach the surface at the speed of sounds in the mud, typically 3,000 to 5,000 feet per second. This wave is attenuated as it propagates to the surface by a dissipation factor, okay? So, is it important to know about the mud pulse telemetry? Yeah, we can see that mud pulse telemetry is an essential part of directional drilling services and is a challenging engineering topic. The final goal of this system is to accurately carry the downhole data to the surface, okay? And then the unit is going to change or convert those digital and analog both or data to an engineering data. Then we are going to transmit that data into the display or floor displays just to the driller, place the well in the right position. And finally of that, if you are with LWD services or not, you're going to deliver a report, your final survey report or your LWD QC logs. So it is important that this data is well transmitted from downhole to surface and well decoded, by the way. So I hope you get more clear about this topic, and if you have any question, just let me know in the comment section. I will appreciate if you like this video, just like it and subscribe to my channel. Okay, bye bye.